This is a revision for HL VSEPR. Okay, let's try IF5. Let's do the same steps as we did for SL. We're going to draw the dot and cross, count the bond pairs and lone pairs, and match the shape. Okay, I has 7 outermost electron. 1, 2, 3, 4, 5. And I'm going to put 2 closer to each other as a lone pair because the other 5 is going to bond with the fluoride. Okay, and fluorine has 7 outermost electrons. So 1, 2, 3, 4, 5, 6, 7. Remember, I told you I insist that we draw every single electron in the fluorine so that we don't forget during exams. Okay, so now we can count the bond pairs and lone pairs. There's 1, 2, 3, 4, 5 bonded pairs and 1 lone pair. Okay, let's go to the table and revise that. So if I have 5 bonded pairs and no lone pair, that will give me trigonal pyramidal. So it's a pyramid here. It's a pyramid up here. And you can see a triangle and another pyramid down here. And it's also triangle based. So we call it trigonal bipyramidal because there's 2 pyramids up and down. So therefore the angles are 120 at the triangle and 90 if we're looking at this to this. Okay, that's 5, 0. If I have 4 bonded pairs and 1 lone pair, it's going to be a distorted shape, or we call it a seesaw. The angles are a bit messed up, so less than 120 and less than 90 if we compare it with the 5 bond 0 lone. So for this SF4, we find that the angles is around 102 here and 86.5 here. And the yellow one here is 173. So that's a bit less than 180, which would be 180 if it is from this CL to this CL. Okay, if I have 3 bonded pairs and 2 lone pairs, I'll end up with a T shape, and that means it's 90 degrees as well. If there's 2 bonded pairs and 3 lone pairs, so the 3 lone pairs will be on the triangle. So actually we go back to the 5, 0. So the 3 lone pairs will take this place, and this place. And so it's only up and down that would be linear. So linear, this way linear, and so 180 here. The lone pairs are surrounding this way at the triangle. And next one, if I have 6 bonded pairs and no lone pairs, I'll get octahedral. Octahedral looks kind of like a square bipyramid. So it's square on this area, and it's a pyramid up here and a pyramid down here. So all of it is 90 degrees. We can look at it as if it's like x-axis, y-axis, and z-axis. So they're all 90 degrees from each other. Okay, so this brings to what we were looking at. If I have 5 bonded pairs and 1 lone pair, so 1, 2, 3, 4, 5, and I put the lone pair anywhere in this octahedral. If I put it here, the pyramid is going to face this way. If I put the lone pair here, the pyramid will be up here. So it doesn't matter where I put, all of them are 90 degrees. Anywhere can be the lone pair. So if I were to put it down here, I get a square here and a pyramid up here. So we call it square pyramidal. So it's 90 degrees, but it might be slightly smaller than 90 because of the repulsion from the lone pair. And if we get 4 bonded pairs and 2 lone pair, then it's a square planar because the lone pair has to repel as far as possible, therefore leaving us with just this square that is flat, so planar. Therefore, it's 90 degrees as well. Okay, so back to our question. We have here 5 bonded pair and 1 lone pair. So it's this one, 5 bond and 1 lone. So it's going to make a square pyramidal. Let's try one with a charge. ICl4 negative. Okay, iodine in the middle. Iodine is in group 17, so it has 7 outermost electrons. So the Cl. Okay, 1, 2, 3, 4. And that's a negative charge. So I'm going to put an extra electron, say here, for the negative charge. Okay, 1, and keep it simple. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 7. Now I'm going to draw for iodine. We'll change the color. 1, 2, 3, 4, 5, 6, 7. So I would have 1 bonded pair, 2 bonded pairs, 3 bonded pairs, 4 bonded pairs, and 2 lone pairs. Okay, now it doesn't matter where you put your extra electron, you're still going to end up with this shape. So if you have 4 bonded pairs and 2 lone pair, so if you look back to your table here, 4 bond pair, 2 lone pairs give you a square planar. Now let's see what happens if you put your extra electron at the iodine instead. Okay, 1 extra electron here, and iodine has 1, 2, 3, 4, 5, 6, 7. Let me shift this closer. Okay, and I'll put in the electrons for the chlorine. 1, 2, 3, 4, 5, 6, 7. So I'm still going to end up with 1, 2, 3, 4 bonded pairs and 1, 2 lone pairs. So it doesn't matter where you put your extra electron from this negative charge, whether you put it on the chlorine or accidentally put it on the iodine, still you're going to get 4 bonded pairs and 2 lone pair. Therefore, your answer is still going to be square planar.